So by the end of today's lesson, you should be able to define an outlier in terms of regression. So we've already talked about outliers in terms of histograms and dot plots, but we haven't really talked about outliers in terms of bivariate data, in terms of outliers, in terms of our X and Y axes. And so we're going to define outliers in terms of regression. We also are going to define something called an influential point, and we're going to distinguish the difference between outliers and influential points. For those of you guys who want to follow along in the book, we're in chapters 8 and 9. And everyone should be working on their 2 homework packets. Remember, the only 2 homework packets that you need to work on are the linear regression homework packet and the nonlinear regression homework packet. Do not worry about the inference on linear regression homework packet, because that is not going to be on the AP exam, and it's not something that you need to know, okay? At least not for the AP exam. You might need to know it if you go on to college and you're like, oh man, I really enjoy stats, and maybe I might become a stats major or maybe a stats minor. If you enjoy stats and this seems like something that you might want to do later on, then you might want to look at the lessons after the AP exam, which will be our inference on linear regression, which is not going to take us very long, to be honest with you. And so everyone should be working on their accelerated math. And once again, if you have any issues at all logging in, just text me, send me a direct message in GroupMe, and then I will reply to you and send you your username and password. Okay, so in regression analysis, a data point that diverges greatly, so a data point that is very far from the overall pattern of data, is considered an outlier. So something that diverges greatly from the overall pattern of data is called an outlier. And there's basically 4 ways that this can occur, okay? You can have an extreme X value compared to all the other components. You can have an extreme Y value compared to all the other data points. You could have an extreme X and Y data point compared to the rest of the data points. And then you can have a distant point that's just different from the rest. It's not extreme, but it is away from the rest of the overall pattern. And I'll show you examples of each of these. So what does it look like for us to have an extreme X? Well, an extreme X might look something like this, where all the X values here are between maybe 0.5 and maybe 8 or something like that, right? And then we have one data point that is further to the right or maybe further to the left. And this would be an extreme X value, because this X value over here is so much different than the rest of the X values here. In terms of the Y values, all the Y values are between 0 and 10. And so this point is also between 0 and 10. So in terms of the Y values, it's not extreme. But in terms of the X value, it is. You can have, of course, an extreme Y value. So something that is either really high or really low compared to the rest of the data points. This could be considered an outlier, and it's an outlier because, once again, this has an extreme Y value. It's not like the rest of the data points in terms of its Y value. It can have an extreme X and Y value. In terms of its X value, it's really far. This outlier right here, it's really far to the right. It's also really high compared to the rest of these data points, right? So this right here, this outlier has an extreme X and an extreme Y. It could also just be some distant point. So if you look here, all of the X values are between 0 and maybe 8 or 9, maybe close to 10. And so this is close to 10, or this is between 0 and 10 in terms of its X value. In terms of its Y value, the Y values all go between 0 and 10, and this is also between 0 and 10. So it's not extreme in terms of our X and Y, but it doesn't follow the rest of our data points, right? So the rest of our data points are following this pattern, and so this is still considered an outlier, and we consider that a distant data point outlier. Okay, so those are the 4 different ways that we can have an outlier based on our regression analysis. So what's an influential point? An influential point is an outlier that greatly affects the slope of the regression line. So anything that has an effect on the regression line is considered an influential point. And so influential points are outliers, okay? But not all outliers are influential points. So let me just say that again. So all outliers, or all influential points, are outliers. However, not all outliers are influential, okay? So all influential points are outliers, but not all outliers are influential. It's kind of like if I said all squares are parallelograms, but not all parallelograms are squares, right? So it works one way, but it doesn't work the other way. So influential points are a subset of outliers, okay? So influential points are a subset of outliers. It's kind of like if I said squares are a subset of parallelograms, right? So squares are a subset of parallelograms, but not all parallelograms are squares. Okay, so an influential point is an outlier that greatly affects the slope of the regression line. One way to test the influence of an outlier is to compute the regression equation with and without the outlier. So if you look at the regression line with an outlier and without the outlier, if the slope or the correlation is greatly affected, then that point is an influential point, okay? So any point that greatly affects the slope or the correlation is going to be considered influential, okay? If you evaluate the slope and the correlation or the correlation with and without the point. Okay, so to put it simply, influential points are data points that have disproportionate effect on the slope of the regression line. So it's mainly about the slope, okay? So this type of analysis is illustrated below. The slope is greater when the outlier is present, so the outlier would be considered an influential point. So if you look at this right here, we have a set of data that follows some linear pattern, and this right here is the same data, okay? So this right here is the same data. The only difference is this data here has this outlier, okay? And it's an outlier because it's a distant point. It's just different from the rest of the pattern, okay? So because it has this outlier, and if you look at it, you look at the slope goes from 104.78 to 97.51. No, I'm sorry, that's the y-intercept. The slope is 4.10, negative 4.10. So if it goes from negative 4.10 to negative 3.32, that is changing our slope. And I would say that that's a fairly significant change in our slope. Because that changes our slope, this point right here can be considered an influential point. Now, generally speaking, influential points generally will have an extreme x, an extreme y, or both an extreme x and y. If it's just a distant point, it's less likely to be an influential point. So although it could still be an influential point, it's less likely to be an influential point. And I'll talk about that a little bit more later on, okay? And if you look at our correlation of coefficient of determination, r squared, or correlation if you square root it, here r squared is 0.94, right? That's a very strong linear relationship, and it's a negative linear relationship in this case. Whereas here, just with that one data point, it changes our r squared to 0.55, and that there is definitely significant. Our slope, some could definitely argue that that's not a significant change. 4.1 to 3.3, yeah, there's a definite change there, but could that just be natural variation? Possibly, I'm not really sure. And so it could be just natural variation. If I took another sample, I could get a slope that's somewhere in between those two. So maybe this is not significant. However, if you look at the r squares, that's definitely significant. To go from 0.94 to 0.55, that's definitely a very drastic change. Okay, so then that would definitely tell me that that's an influential point. Okay, so that being said, see if you can answer this question. Which statement about influential points is true? Removing an influential point changes the regression line. Data points that are outliers in the horizontal direction are more likely to be influential than points that are outliers in a vertical direction. Influential points have large residuals. And so the correct answer here, I'll let you think about it. So Shaolin says 1 and 2. And no one else is answering, so I'll just tell you. It is 1 and 2, so that's exactly right. So a linear transformation neither increases nor decreases the linear relationship between variables, okay? So it preserves the relationship. So a nonlinear transformation is used to increase the relationship between variables. The most effective transformation depends on the data being transformed. And so, wait, I don't know what, maybe that's weird. That's weird that I say that. So removing an influential point does in fact change the regression line. That's why it's called influential. So that's why 1 is true. This solution, I'm not really sure where that came from. Data points are outliers in the horizontal are more likely. So that is true, actually. Something that's influential, something that's more of an outlier in the Y value is actually going to be a little bit more resistant. And I'll show you that, and I'll give you an example of that in a second, okay? And then influential points have large residuals that may or may not be true. Okay, so influential points that have may or may not have large residuals. So that's pretty much the lesson, but let me do this really quick. Let me show you some examples of things here. Oh, sorry. Let me do this. Okay, so, and then let me also do a pen. Don't know if I could do a pen. It doesn't let me do a pen. Okay, well, that's not good. Let me do it this way. I'll just do it on the bottom of this. So let's see if I could do a pen here. Okay, so let me show you some different examples of what you might see. Let's say, for example, I have a bunch of different points like this. Okay, so I have a bunch of different points here like this. Okay, so first and foremost, if I ask you, what's the correlation here? Okay, so what's the linear relationship? Can we say that this is even linear? And as long as it's not curved, we can say it's linear. I could draw a line through that. Okay, so I can draw a line through that. The line that I happen to be able to draw through this would be just a, oh, that's awful. So let me just undo that. Or can I undo that? Maybe I cannot undo that. But that's awful. Would be more horizontal. Okay, it's going to be more horizontal. So in any case, I would say that there's no correlation here. There's no linear relationship. It's just a random scatter, right? But what happens if I take a point way over here? So let's say that there's an outlier way over here. Well, now, if I want to draw the point that's going to be closest to this, it's going to look something maybe like that, right? So this right here actually does not have a, it actually does not have a large residual necessarily, okay? In fact, this line might actually even pass through that point. You might actually get something that looks maybe a little bit more like this, where it actually goes through it. And so that's definitely an influential point. It's changing our slope from 0 to this slope here. And so this influential point, this outlier right here, would definitely affect my results. Okay, so this right here, it would affect my slope. It's going to affect my correlation. And so that's an outlier. That's an influential point. And it does not have a large residual. In fact, it has a very, very, very small residual. So what happens if I, and I'm really sorry about this, but I'm doing this on my Mac. And on my Mac, it does not allow me to work on PowerPoint very well. But let me show you some other examples of what could happen. So let's say we have, and it's really hard to draw dots with this. But in any case, let's say that I have something like this, and imagine that each of these are dots, not little lines like that. But let's say we have something that looks like this, okay? And let's say that we have quite a few data points. This is definitely going to give me a linear association. There's definitely a linear association between my data points here, right? I could definitely draw a line through here. This has this linear pattern. Okay. And so I could draw a line through here and it would look something like that, okay? So that's my line. Now that being said, what happens if I have a point that's like right here? So let's say we have a point right here, okay? How is that gonna affect my slope? How's that gonna affect the slope of my LSRL? If you think about it, it might take this line and it might shift it up slightly, but I don't know if it's going to actually affect my slope that much. This point is far from the rest of my data points, but it's really not that far, right? So it's not that far from my data points. And so this is an outlier. I would not say it's an influential point because it's going to shift this line up slightly, but, and let me go ahead and maybe draw what I think that might look like. And I'll choose a different color. It might look something like this now. It might go like this, okay? So it might go something like that. And I apologize, that line is not great, but I'm trying to use my trackpad here and it's not that easy. But in any case, it might shift it up slightly. But if you look at the slope is not really changed that much, right? The slope looks very much the same. And because the slope looks very similar, I'm not going to say it's an influential point. It doesn't look like it's changing it quite drastically. And so I would say that this point is definitely an outlier, but not necessarily influential. Okay. And so influential points, in this case, the residual would be larger than the rest of the data points for sure. I would definitely still say that this is linear. And remember, one of our rules for regression, for us to do linear regression, is we don't want to have any outliers. And the reason we don't want to have any outliers is one outlier, one data point can drastically change our relationship. And so going back to something like this, so let's say we have a bunch of data points here. Let's say we have like 1,000 data points here. Okay, so let's just pretend we have 1,000 data points here, and they form a small cluster of random random dots. And so this right here would be no correlation. Okay, so this right here has no correlation because all I have is a random scatter of data points. So anytime you see a random scatter of data points for your original graph, we're going to say that there's no correlation there, right? And let's just pretend there's 1,000 points here. So obviously I don't want to draw 1,000 little dots here, but just pretend that that's 1,000 points. But if I have some really, really far point right out here, right? So that's an outlier, definitely influential. What's that going to do to my regression line? Well, now my regression line is going to look maybe something like that, right? So now we get this regression line. And so we go from 0, once again, we go from 0 to something like this. And so this right here, right, we don't want one data point to completely change our equation. We don't want to go from no correlation to a very strong correlation. This actually has a very strong correlation, right? So look at that. All the data points are close to the line, right? All the data points are close. And so we would actually say this is a very strong correlation. We went from a correlation of R equals approximately 0, right? So approximately, and I apologize for that approximate symbol, but that's as close as I could get. From R equals approximately 0 to this line, where now maybe R is going to be approximately 0.8, okay? So maybe it's going to be 0.8. And so in that case, we don't want to go from 0 to 0.8 because of one data point. What's more likely is someone typed something in incorrectly, right? It's possible that just when we're collecting data, sometimes we collect data and we have a typo in there. That happens. So that could happen because look at how far this is. This seems really odd, especially if I have 1,000 data points over here and I have one data point over here. Could that happen just naturally? Sure, that could happen. It's just not likely to happen. And so one of our rules for linear regression is we don't want to see any outliers. And so what we would do is we would actually remove that point. And oftentimes what we'll do is we'll actually record both. We'll say, okay, well, here's the data with that data point, and then here's the equation or our data without that data point. And the only reason we might include or we include and exclude it is we exclude it because it's more than likely a mistake. And we include it just in case it's not, right? So if it's not a mistake, we don't want to be accused of tampering with the data or manipulating the data or anything like that. But it's possible that it is a mistake, right? So we're gonna present both data, and we're gonna say that this seems awkward for some reason. We have this one outlier. We're not really sure why, or maybe we do have a reason why, right? So if this data point is not a mistake, there might be a reason why we have this one data point. Okay, so if you were to look at, for example, if this was giving us a relationship, I don't know, whatever the relationship is, it looks like there's no relationship, and it shouldn't be that one data point says now that there is, right? So that's the one thing we don't want to say is, oh yeah, there's no relationship, but if we just add one point, this one point now makes it a strong relationship. That just doesn't make sense. And so once again, statistics should make sense. And if it doesn't make sense, it probably doesn't make sense for a reason, right? So one of the things you want to ask yourself is, does that make sense? Does it make sense that one data point is now going to make a strong relationship, whereas before we were thinking that there wasn't? No, it doesn't make sense to have 1 point. Okay, so that's pretty much it. Like I said, this lesson is super short. There's really, I just wanted to talk about outliers and influential points. You're more than likely going to see a question like this. If they ask you a question on regression, they're probably going to have something about outliers and influential points in there, I would imagine. So I wanted to talk about it. I wanted to give this a proper amount of attention. And so I just wanted to be sure that you guys are comfortable with this and that you understand the difference between an outlier. So this is an outlier, but it's not influential. And an outlier that is influential. So this is an outlier that is influential, right? So something that affects the correlation or the slope of the regression line drastically is considered influential, okay? So outliers may or may not do that, okay? So outliers may or may not do that. Well, that's the end of our lesson. Thanks for watching. I hope this was helpful. Bye for now.